Question 1. Function f is defined by function f such that x is converted into 1 over x squared where x is not equal to 0. We have f of x equal to 1 over x squared. X is our variable. A. Express f2, f3, and f4 in the simplest form. f2x refer to f of fx. We substitute the fx into the function f. We get 1 over fx squared. To substitute the fx, we have 1 over x square, which is 1 over x over 4, x power 4. Then we are asked to find f3x. So for f3x, is either f square fx or f square x. For this one, we will try both ways to compare the answer. The first one is f square fx. The object will be fx. We need the information from the first part to obtain the formula for f square. So this is f square x. We get fx power 4. What is our fx? 1 over x squared power 4, which is 1 over x power 8. So if we're going to do f squared into the f, we need our f. What is our f? 1 over x squared. 1 over f square x square. 1 over f squared is equal to x power 4. So we get the same answer. Either way, we can get the value for f3x. Then we are asked to find f4x. So f4x, there are more ways of doing it. Either we do f3, or we can do f3f, or we can do f square. Let's try f3. We have f of f3x. Substituting the f3 into the f. 1 over x squared. X is substituted by x3x. What is our f3? 1 over x power 8. We get 1 over x power 16, which is x power 16. The other two ways will give us the same value. I'm not going to try it. You may try it yourself. Let's make a conclusion from all our findings. For fx, we have 1 over x squared, which is x negative 2. For f2x, we have x power 4. f3x, we have 1 over x power 8, which is x power negative 8. And f power 4, we have x power 16. By looking at the number 2, 4, 8, and 16, they are all numbers with base 2. 2 is 2 power 1, 4 is 2 power 2, 8 is 2 power 3, and 16 is 2 power 4. We can generalize them. X negative 2 power 1 This will become x2 power 2. X negative 8 will be x negative 2 power 3. And x16 will be x2 power 4. Therefore, we can conclude that Fn of x is equal to x power negative 2 power n when n is odd. And Fn will be equal to x2 power n when n is even. This is an important finding. For B, we are asked to find F22 and F33. We need to use our finding to obtain the value for F22 and F23. We are not going to do it one by one. Since we already have a conclusion for that, we can obtain the value immediately. F22x, 22 is an even number. We are just going to substitute it into this function. So F22x, we will get x power 44. F33x, 33 is an odd number. X negative 2 power 33, we get x power negative 66. Question 2. The function f and g are defined as function f such that x is converted into 1 minus x and function g such that x is converted into px squared plus q respectively. If the composite function gf is given by function gf such that x is converted into 3x squared minus 6x plus 5, find the following. Here we have three pieces of information, fx, gx, and gfx. Let's write it down. Fx equals to 1 minus x. G of x is px squared plus q. And gfx is equal to 3x squared minus 6x plus 5. A. Find the value of p and of q. Since we are given a gfx, let's find our own gf. G of fx. Substituting the f into the g. Look at the g, we get p. Fx squared plus q. Substitute the f. 1 minus x squared plus q. Expand it, we have p 1 minus 2x plus x squared plus q. Then expand it. P times 1, we get p negative 2px plus px squared plus q. Let's group them together and rearrange it. We have px squared minus 2p plus p plus q. Group it accordingly into x squared, x, and a constant. Then we compare our answer with the given information. As comparison, p is the same as 3. P equal to 3. You can also use the second piece of information if you want. You can take negative 2p is the same as negative 6. P will be negative 6 divided by negative 2, which is 3 as well. And then the constant, p plus q is equals to 5. We already obtained the value of p earlier, so it's 3 plus q equal to 5. Q will be 5 minus 3, which is 2. Now, our gx is equal to 3x squared plus 2. B, we are asked to find the value of g squared negative 1. We can either find a general function for g squared, or we can find the answer for g negative 1 and substitute it into g. For this question, we're going to try the second method, g negative 1. We have 3 negative 1 squared plus 2, which is 3 plus 2, 5. G squared negative 1 is the same as g negative 1, which is g 5. Substitute 5 into function g. We get 75 plus 2, 77. Question 3. Given that function f such that x is converted into 2x minus 3, function gf such that x is converted into 2x minus 2 over 3, and function fh such that x is converted into 2x squared minus 1. Find the expression for the functions g and h. We have fx, gfx, and fhx. Fx is equal to 2x minus 3. Gfx is 2x minus 2 over 3. And also fhx is 2x squared minus 1. We are asked to find the expression for functions g and h. Let's do it one by one. Gfx is equal to 2x minus 2 over 3. So g is the outside function. What can we do is we substitute the f, g, 2x minus 3 equal to 2x over 2 over 3. We need to make the object into one singular variable. Let y equal to 2x minus 3. 2x will be y plus 3. X is y plus 3 over 2. Let's continue. We have g of y is equal to 2. Since we already changed the object to y, we have to change the x into y as well. Y plus 3 over 2 minus 2 over 3. Simplify it. Y plus 3 minus 2 over 3. We get y plus 1 over 3. You might want to change it back, or you can just leave it. Gx will be x plus 1 over 3. For hx, f hx is 2x squared minus 1. This part is our hx. We can just substitute the h into the f because we are given the function f. 2hx minus 3 is equal to 2x squared minus 1. Bring the 3 over. Divide both sides by 2. We obtain h of x is equal to x squared plus 1. Question 4. Given that function f such that x is converted into ax plus b and function f3 such that x is converted into 27x plus 13. Find the following. We have two pieces of information, fx and f3x. F of x is ax plus b. f3x is 27x plus 13. A, find the value of A and of B. We have to find our own f3x. In order to get f3x, we need to find f square x first. F square x is equal to f into fx. Substitute the f into the f, we have a fx plus b, which is ax plus b plus b. Expand the bracket, we get a square x plus ab plus b. We continue to find f3x. f square x. So we are substituting f2x into the f. We get a f2x plus b. What is our f2x? We just obtain it, a square x plus ab plus b plus b. Expand it. We get a cube x, a square b, a b, and b. We compare the expression we get with the given information. The ones that containing the x is this. As comparison, a cube is equal to 27. A will be cube root of 27, which is 3. Then a square b, ab and b, this is all compared with 13 because they do not have any x. A square b, ab plus b is equal to 13. Since a is a 3, 3 square b, 3b and b is 13. 9b plus 3b plus b equal to 13. 13b is 13, so b will be 13 divided by 13. b equal to 1. So our function fx is equal to 3x plus 1. B. Find the expression of f4x. f4x is equal to f3x. We are going to substitute f3x into the f. Our fx is 3x plus 1. We got 3 f3x plus 1. f3x is given 27x plus 13 plus 1. Then we expand the bracket. 81x plus 39 plus 1. Simplified, we get 81x plus 40. Question 5. A cylinder container of radius 20 cm contains 200 cm cube of water. The container is filled with water at a constant rate of 100 cm cube per second. We have a few pieces of information, radius, the volume, and also the rate. Radius is 20 cm, volume is 200 cm cube, and the rate is 100 cm cube per second. Write a formula of the amount of water in the container V after t second. So we are going to write a formula for the amount of water after t second. The rate is actually equal to amount of water divided by the time. So in order to find the amount of water, we take the rate multiplied by the time. So amount of water is given V. So V is equal to the rate 100 times the time T. So we obtain the formula for amount of water. A2. Write the formula of the height of water in the container H in terms of V. The container is cylinder in shape, so we have something like this. And the water. This will be the height, and this will be the radius. The water will take the shape of the cylinder, and the formula for volume of cylinder will be pi r square h. Amount of water is the shape of the cylinder, which is pi r square h. Amount of water is symbol V is equal to the pi. Radius is given 20 square h. We need to write a formula of h in terms of V. H will be V divided by 400 pi. A3. Write the formula of the composite function HVT. HVT. The answer that we obtain from A1 is actually V of t. And the answer that we obtain from number 2 is H of V. Now we are going to find HVT, meaning we are going to substitute the VT into the H. Our H is V over 400 pi. Since our V become VT, we will have 100T divided by 400 pi, which is T over 4 pi. And B, find the height of water in the container after 20 seconds. So when T equal to 20 seconds, what is our height? Basically, we are finding HV 20. Substitute the 20 into the T. 20 divided by 4 over pi. You get 5 over pi cm. So that's it for today's tutorial. Hope it will help you in your study. See you again in the next video.